Hi, welcome to the Unit 3 notes video. We are beginning Unit 3, which is talking about chemical bonds and intermolecular forces. I'm going to zoom in just so that you can see that a little bit better. So I-N-T-E-R, molecular forces. These are the forces that are between molecules. Our objectives for this unit are: 1, to learn about the types of bonds and properties associated with those types of bonds. Then we're going to take a deeper dive into ionic bonds. We're going to look at how do we name ionic compounds and determine their formulas from their names, and draw what's called a Lewis dot structure representation of an ionic bond. Then we'll move into covalent bonds, and again we'll focus on the names and formulas and drawing Lewis dot structure representations. Next, we'll go into shapes of molecules and discuss how the shapes of the molecules help determine whether a molecule is polar or nonpolar, so determine its polarity. And then we'll learn how the polarity helps to determine the intermolecular forces and the associated properties like melting point and boiling point. The essential question for this unit is: which property of an atom do you think is most significant in determining properties of matter? And that's on the molecular and the bulk scale. So that's our essential question. So if you need to, take a moment, pause the video, and copy the information for your Unit 3 title page. Okay, so as we're saying, we're talking about molecules and bonds and things. So let's get started with some key information here. Okay. So for Unit 3.1, it's the types of bonds and properties. And the first thing we want to do is define what a chemical bond is. So a chemical bond is a force that connects atoms together in molecules. So the force that connects atoms together in molecules. And all chemical bonds involve the attraction of a positive part, which could be the nucleus or a cation, to a negative part, electrons or anions. Okay? So let's take a look at some representations of bonds here. And we have some models that we can sort of use to show. So here we have a model of formaldehyde, the thing that's used in biology to preserve specimens. These are hydrogen atoms. This is a carbon atom. And then on top we have an oxygen atom. So this is a model of formaldehyde. And you'll see that there's 2 bonds here between the oxygen and the carbon. So the bonds are what's connecting the atoms together and keeping this molecule together. Okay? So that's what we mean when we say a chemical bond. Now these bonds specifically are covalent bonds, but there are other types of bonds like ionic bonds. And they look different, but in all cases, the bonds involve some sort of negative part, which in the case of covalent will be the electrons, and some sort of positive part, which will be the positively charged nucleus in a covalent bond. It sort of keeps them together. Okay. Now the question may be, well, why do atoms form bonds? Why would this hydrogen want to bond to that carbon instead of just being a free hydrogen? The reason that is that atoms bond to each other to make a molecule, and they do that because molecules are more stable than an atom. So the hydrogen inside of the formaldehyde is more stable than a single hydrogen atom. So if you were to have a single hydrogen atom and a formaldehyde, a hydrogen in the formaldehyde, this hydrogen is more stable than this free hydrogen atom. Now there are 2 driving forces that make the molecule more stable. One has to do with atoms wanting to have a full or valence shell or noble gas configuration, which we'll talk about a little bit later. But the main idea being that, remember, we learned from Bohr models that the first shell can fit a maximum of 2, and then all the other shells can fit a maximum of 8. Now, even though we say maximum, it's really saying satisfied. So the second, third, and fourth shells are all satisfied with 8 electrons. And they're happy that way. And so they're trying to get to that. And one way of getting to that is by forming bonds. The other thing that it has to do with is that when you have that configurations, the electrons are able to pair up. And remember, when electrons pair up, they sort of pair up like two magnets. And it sort of helps to stabilize them, like a north pole and a south pole. That's why they have opposite spins. So that actually also helps to stabilize them. So getting that noble gas configuration and electrons being able to pair up. Okay, so we went over what chemical bonds are and why atoms like to form bonds. Now let's talk about the main types of bonds. There are four main types. And the four main types depend on the type of atoms that are in the bond, okay? And all of these different types of chemical bonds will make different types of molecules that have different properties. So before I move on to what the four types are, I want you to take a moment to copy this information down, and then we'll go into the four types of bonds. Okay. Now let's talk about the four types of bonds. I'm going to just move this down a little bit so we can see. Okay. And I'm going to have to zoom this out just so you can see sort of what the setup looks like, and then I'll zoom it back in for each individual section. All right, so I want to be clear about what I have going on here. I have a table of that's divided into 2 rows and 2 columns. So that's what you want to have as your setup. Like this is, I split that in half. And then I drew a line underneath to split the 2 columns and rows. And in each quadrant, I have a different type of bonds. So we have metallic bonds, which make metals, ionic bonds, which make ionic compounds, covalent, molecular covalent bonds, and network covalent bonds, okay? So we're going to focus on one at a time, but this is sort of the general setup. And then here at the bottom, I have some key terms, which we'll go into later. So let's zoom in on our first type. And that is that are the metals, okay? So let's talk about some things about metals. All right, so first of all, metals are made up of metallic bonds. And the types of atoms, if you have a substance that has metal atoms only, then you'll have a metal. Now, when I say metal atoms only, you may be thinking, what are you talking about? Remember that the periodic table, and I'll just flip back into the notes there. If you look on your periodic table, you will see that the left-hand side and towards the middle, that's where you find the metals. The non-metals are on the right-hand side, and the metalloids are in between. So what you're looking for is if you have a molecule or a substance that only has atoms that are considered metals, classified as metals, then you have metallic bonds. Okay, so let's talk more about metallic bonds. So they are made of metal atoms only, and what they contain is a metal nucleus. The bond is described as a metal nucleus floating in a sea of electrons. Okay, so what do I mean by that? Here, these yellow dots represent, or the yellow circles represents the metal nucleus, which is positively charged, and the core or inner electrons. Since there are fewer inner electrons than there are number of protons, this is actually positively charged. So these all have positive charges because you have fewer electrons than protons. The valence electrons, which are the electrons on the outermost shell, they sort of move around. They're not necessarily tied down to a single atom. So the nucleus and the core electrons can float in this sea of electrons. So it says metal nucleus and core electrons floating in a sea of electrons. That's how we describe this type of bond. So what are some properties of this bond, of these types of substances? Well, they're solids. Most metals are solids, with the exception of course of mercury. They're mostly gray or silver. They're shiny. Many are good conductors, meaning that they can pass heat So they're heat conductors, and they also can pass electrical current. Usually when we say conductors, we focus on the electrical current. Another property is that they're malleable. So if you hit them or you drop them, they're going to bend or dent, but they're not going to break. They're not brittle. They have high melting points and high boiling points. They're insoluble in water, meaning if you take a piece of metal and you put it in water, it will not dissolve. And this may be hard to read, so I'll zoom in there. Most of them are hard, H-A-R-D, with the exception of group 1 and group 2 metals. So exception of alkali and alkaline earth metals. Most metals are actually hard. But the alkali metals, like sodium, for example, you can cut that with a knife. They're not very hard. Okay, so that's metals. Let's go in now to ionic compounds. In fact, I'll pause it here in case you want to pause to copy notes. Then we'll move on to ionic compounds. All right, for an ionic compound, those are made up of ionic bonds. And usually you can tell them because they're made up of a metal and a nonmetal. So for example, sodium is a metal, Na is a metal, and Cl is a nonmetal. So that's an ionic compound. You know the bonds here will be ionic bonds. Calcium sulfate. Calcium is a metal, Ca is a metal. Sulfur and oxygen are nonmetals. So again, this is ionic. Now there is an exception here that I sort of want to note for you all. In addition to metals and nonmetals, ionic bonds can also be made up of the cation NH4+. So we're going to add metals and, that's my and symbol, NH4+. That's called ammonium NH4+, okay? So it can be made of NH4+, which is it's not a metal, but it acts like a metal, or metals, and then a non-metal part. So an example, I'll just write an example of that. This is an ionic compound. So you have this part and that part. So this is acts as a metal, this is our non-metal part. Now what exactly is an ionic compound? An ionic compound, and we'll look more to it later, is made up of two parts, a cation, which is usually written first, so this will be our cation, NH4+, and an anion, which is written second. And you can see that in the drawings here. So the purple, and I'll zoom in a bit, the purple circles with plus signs, those are our cations. Cations means things with positive charges. And the green circles are our anions, they have negative charges. Now, one thing that's important to note about the ionic bonds is that the anions are larger than the cations. That's because the anions gain electrons, so they get a bigger, sort of radius. They're adding electrons into their shell, so they get bigger. Whereas the cations have lost electrons, so they're going to have a smaller shell. All right, so I try to keep the anions bigger than the cations. All right, so let's talk about what this bond is. This is described as an ionic lattice. So it's made up of cations and, of course, forgot to put that in there, anions, negative, okay? Cations and anions. So properties of ionic bonds, ionic compounds, they're solids. They can have different colors, so various colors. They're dull, unlike metals that are shiny, they're dull. Now, in terms of conductivity, they're insulators as a solid. So if you take a clump of salt, like this sodium chloride, that's table salt, and you stuck a conductivity meter into it, it will not conduct. But if you dissolve it, so that's AQ stands for aqueous, or you melt it down into a liquid, L is for liquid, then it will conduct. Other things are that they're brittle. If you were to hit them or drop them, they're going to break apart, unlike a metal which will dent or bend. Many ionic compounds are soluble, meaning they will dissolve in water. And like metals, they have high melting points and high boiling points. And one of the reasons why both metals and ionic compounds have high melting points and high boiling points has to do with this bond structure, which, as you can see, it's sort of set up as like a network. Okay, they're not discrete; they're sort of set up together. There's not an individual, just one chunk. Which when we look at covalent, we'll see that looks a little different. So anyway, so that's the key things about ionic compounds and bonds. So I'm going to zoom in So if you want to pause, you can take your notes. Okay, so let's do the last two. The next one we're going to focus on here are covalent molecules. And they have molecular covalent bonds, molecular covalent. The types of atoms, nonmetals only. So, for example, water, carbon dioxide, NH3. This is table sugar. All of these atoms, hydrogen, oxygen, carbon, nitrogen, they're all nonmetals. So if you have something with only nonmetals, you know it's a covalent molecule. Now, in these types of bonds, the electrons are shared between the atoms to form a bond. So this line, this is a water molecule, that's oxygen and 2 hydrogens. That line is actually a pair of electrons that's connecting these two atoms, the oxygen and the hydrogen. So what are some properties of these bonds, of these types of molecules? First of all, in terms of phases, they can be solid, liquid, or gas. In terms of color, many are white or colorless, but they can be any color really. There are some that are yellow, all different sorts of colors, but usually they're usually white or colorless. They're dull. In terms of conductivity, they're insulators, except aqueous acids. So aqueous acids. In terms of solubility, many are polar. So if there are many polar molecules, if this molecule is a polar molecule, it will be soluble. But if it's nonpolar, it will be insoluble. And they have medium to low melting points. Okay. Now the reason why these have low melting points is, as you can see, if you compare this to the metals or the ionic bonds, this bond is discrete. This is one water molecule. It's not connected in a lattice or a network like these are all connected together. So that's the reason why this has a lower melting point and boiling point. If you need to pause the video to take the notes, zoom it in a little bit. All right, last one is the network covalent. Now you actually don't need to know this too much. We're not going to spend too much time on this, but it's kind of important to note because these are important compounds. So network covalent solids, which make up network covalent bonds. So the molecules themselves or the substances themselves will be called network covalent solids, and the bonds are network covalent bonds. So these are the things that are made up of, the types of atoms will be carbon only, like diamonds or graphite. They're also going to be made of metalloids. So remember the elements in the middle of the periodic table between the metals and nonmetals. If you have things like silicon and oxygen, that's actually like what sand and glass are made of. They're called silicates, silicon and oxygen compounds. Those are also network covalents. So carbon only, metalloids like silicon, Si, and germanium, or things that are made up of silicon and oxygen. Now, if you look at the network covalent solids, they are similar, set up in a network or a lattice like the ionic compounds. They're all sort of connected together. There's not a discrete portion. And these are a network of bonds. Now, in terms of properties, solids, the colors are usually earth colors. Many are semiconductors. You have quite a few semiconductors here. They're insoluble. They have high melting points and boiling points, and they're hard as well. And once again, that these characteristics or these qualities for them being high melting point and high boiling point comes from the fact that their bonds are arranged in a network. It's not discrete individual sort of molecule like you have here. Okay, so if you need more time to take the notes for network covalent solids, pause the video. Okay, now at the bottom of the note document here, I have just some key terms, which I won't necessarily go over with you because it's hard for me to do this at the same time, but I do have a PDF of the notes, so you can copy the notes there. But it just has the key terms of the properties that we're looking at. Like, for example, what does soluble mean? It means it dissolves in water. Insoluble means it does not. Insulator is the opposite of a conductor. Conductor passes electrical current or heat. BP and MP, those stand for boiling point temperature and melting point temperature. So those notes are there. And again, I have a PDF of this so you can copy. All right, so let's just sort of summarize. The main thing here is that there are different types of four main types of chemical bonds. The types will be determined by the types of atoms. So if you have metal atoms only, it's a metal. If you have metals and nonmetals, it's ionic. If you have nonmetals only, it's covalent. And if you have these specific nonmetals, carbon only, silicon and oxygen, or metalloids, it's network covalent. Now, the types of bonds determine the types of properties that each of these substances have. So metals have certain properties, covalent molecules have certain properties, ionic compounds have certain properties, and network covalent solids have certain properties. So that's the main point of this video. So make sure you have these notes copied down. It sort of summarizes everything you need to know for this section. All right, I hope you found it helpful. And if you need to see this stuff again, there will be a PDF of the notes. Have a quality day.